In this lecture, everyone, I'm going to discuss about a three inbuilt function which is available inside a Python. Again, inbuilt function wise, there are so many inbuilt function which is available inside a Python. For example, a print function, length function, type function, list function, tuples function. So many different kind of a functions which is available inside a Python. But here in this lecture, I'm going to discuss about a three very important inbuilt function inside a Python, which is called as map for a mapping, reduce for reducing, and filter for filtering. Again, we'll try to understand with respect to an example that what is map, what is reduce, and what is a filter one by one. So let's get started and let's try to understand what is a map function. So let's suppose I have a list of the number over here, and inside this list I have a couple of numbers available. Okay, so the other number which is available inside my list. Now if someone is going to tell me that try to find out a square of each and every number which is available inside a list. Now I can do it in a multiple way. I can do it just by writing a simple regular function. I can even do it with the help of a lambda function, and there is another way by which I will be able to perform a same operations by using a map function. See, what map function does is, so let's suppose this is the collection, right? So it will try to map operations with each and every element which is available inside a collection. Obviously you all will be able to understand it in a clear way once I'm going to give you the example, once I'm going to write a code. So let's suppose if I'm going to create square, a square variable, I'm going to write a lambda. Instead of lambda you can write a full-fledged function as well. So lambda, and here what I can do is, so maybe I can try to take a input. So maybe input as x is nothing but any kind of a data which I can try to pass. In this case, data is going to be my list. And then what I can do is I can try to maybe write static power 2. Okay, so this is something which I'm able to write it down. Now this is something which I'm going to write for what? I'm going to write to square each and every number. So just look after this function. So if I'm going to input one number, it is going to do a square of that number. Technically, this is what this lambda function is going to perform. Now I'm going to call this lambda function into a map function. There is a function called as inbuilt function called as map function. Now, if you will look into the map function, it takes two parameter. It takes two argument. One argument is a function. So it can be any external function or maybe a lambda function you can try to write. So here you can try to pass any kind of functions, and then second argument in general you are going to pass as a iterable object, maybe a list, maybe a string, maybe a tuples kind of a iterable object you can try to pass. So what it will do is it will try to map, just try to focus on this word. So this map is a inbuilt function, right? I'm not creating it. It's an inbuilt function inside a Python. So it will try to map each and every element of this particular iterables with this particular function which I'm going to pass. So let's suppose if I'm going to write that, okay, so try to map this one with a numbers, execute. Now, if I'm going to execute it and if I'm going to call this square, you will be able to find out a mapper object. Mapper object is nothing but collection kind of a things you will be able to find out. If I'm going to convert it inside a list, you will be able to see the final outcome. So here you will be able to find out that it is trying to perform a square of each and every element, and then it is giving me the result. How it is going to work internally, let me explain you once again. See, there is a function called as map function. Now what is an objective of this map function? Map what? So map all the element of the data. So this is my data which I'm trying to pass. A number is a data which I'm trying to pass. So map this entire data set or whatever data which is available inside this collection. So map each and every element one by one with this function. Means, so it will go to this particular collection, it will try to pass 3, so 3 of a square, then 4 of a square, 5 of a square, 6 of a square, 5 of a square, 6 of a square, 7 of a square, 7 again, 7 of a square. So it will just try to do a mapping of this element, this collections element with this particular function, and it is going to give me the result. So this is what a mapper does. So wherever you have to perform an operations, a kind of operations where you would like to map each and every data set with some of the operations, map function is going to be a handy operations. Now, here I'm trying to mention a lambda. Let's suppose I'm going to write an external function. So def and then maybe a test. Now what this test will do? So this test will take input of any number, let's suppose x, and then it is going to return what? So maybe x of square it is going to return. This is the external function I'm writing. Okay, this is the external function which I'm trying to write. Now I have to solve the same problem, right, which I was trying to solve by writing a lambda function over here. So I can try to solve it. I can call a map what? So map this particular function with what? So this function I'm trying to call, which is nothing but a test, and then map with what? Map with a data, which is a number. So this is a mapper object it is going to return. So if I'm looking for an outcome, so maybe I can try to convert it, this entire outcome, into a list. I will be able to get a data. So I'm just trying to pass external function. It could be a lambda function, it could be external function. So let's suppose I have to do a very, very complex implementation with respect to each and every element, right? I can just try to map by using just a map function. I can write a lambda, or maybe I can try to write a external function. In either way, it is going to work for me. That's completely fine. Now, let's try to understand maybe some other example. So here, let's suppose I have a list. So I have a list. Inside this list, I have SUDH and SHU. I have basically KUMAR, and then I have maybe PYTHON, Python. I have maybe Java over here. Okay. So this is a list which is available with me. Now what I'm supposed to do? So I'm supposed to convert every element without any exception, every element of this particular list into an uppercase. That's a requirement for me. Now how I will be able to do it? With the help of map function. I just have to write some external function where I have to map those functions in such a way that everything will be converted, means each and every individual element will be converted into an uppercase. I can write it maybe external function. So maybe upper case function. It will take input, maybe input as a, and whatever input you are going to give, it is going to return a dot upper upper. It is going to give us a return. This is the external function I have written. So it is going to take only one element, not a collection. It is taking only one element. Now I have to perform this operation with respect to every element. So what I will do, so maybe I can try to call a map. So here, uppercase, I can try to call, comma, I can try to pass a list. Simple, execute. It is going to give me the mapper object if I'm looking for the outcome. So maybe I can try to convert it into a list or maybe a tuples. I will be able to see the outcome. So here is my outcome. It is mapping. It is mapping each and every element of this list with this function. Means one by one, it is trying to pass a data. And finally, it is going to return me the map iterables, which I can try to convert into a list and I can see the outcome. Simple, mapper function. Now, let me give you another example. So let's suppose I have a list over here. And inside this list, I have a number. But numbers are available into an string. So here is a number. Okay, and numbers are available into a string in this particular list. So numbers are available into a string in this particular list. Now what I'm supposed to do is I'm supposed to convert every element inside this list into a numbers. As of now, there is a number, but it's available into a string format. So I have to do a typecasting operation, but I have to do a typecasting operation for every single element inside this particular list. Okay, so maybe I can write an external function or maybe I can try to write a lambda. Either way, it's going to be work fine. So map, and then map takes two arguments. One is a function, another one is a data or collection or iterables. So here lambda, I can lambda, lambda. So which will take x means one element it is going to take, and then it is going to convert every x into an integer. So this is the function which is going to work on individual element. I can pass a list over here. So it is going to give me the map object. Now I can try to do a typecasting into maybe a list or maybe this time into a tuple tuple. I will be able to see the outcome. Now tuples element, or maybe I can write a list. I will be able to produce a list over here. So here every element you will be able to find out it's available into an integer or number format. Right? I'm just doing a typecasting operation. So I'm not iterating over to it. So mapper is going to do an iteration for me with respect to this particular iterable object. Simple, right? So map one by one, one by one, one by one with this function that you are going to pass as an argument. So map always takes first argument as a function, second argument as a collection. Okay, let me show you some other example, okay, with respect to a map function. So here what I can do is, so maybe I have a list L1, and inside this list L1 I have a number, 4 number I have, and then I have a list L2, and again I have a 4 number inside this list L2. Now someone is telling me that can you please try to add an element of this index wise addition, means 3 plus 4 return, 4 plus 5 return, 5 plus 6 return, 6 plus 7 return, means I have two separate lists. I have to do an addition operation, right? I have to do an addition operation and then I have to give a return. This is the requirement of a map function which I'm supposed to, or this is the requirement which I'm supposed to solve. Okay, not an issue. I can write a map function. I can try to write maybe a lambda function over here. So lambda will take two input, x comma y, and it is going to return x plus y, right? And then I'm going to pass my L1 and I'm going to pass my L2 over here. Simple, right? And let's suppose, sorry, L1, right? L1 is this, L1 and L2. And I'm going to convert everything, whatever is going to be the outcome, into a list format, list format. And then I'm going to return. Now here is a magic. So what it is going to do internally. So see, I have written a lambda function. Okay, I have written a lambda function, which is going to take two argument. Fine. I have given two lists over here, two collections over here. So it will go to this collection, index 0, 1, 2, and 3. Okay, 0, 2, and 3. So here, x is going to be 3, y is going to be 4. X is going to be 3, y is going to be 4, 3 plus 4, 3 plus 4, 7. Again, x is going to be 4, y is going to be 5. So it is going to take an argument from this one and this one together. Okay, it is trying to do a mapping operation. So mapping operations, and then whatever operation that you have written, it is going to perform that operation and give you the return. So again, this is another implementation of a mapper function, which you will be able to find out very, very useful whenever you have to perform such kind of operations. Okay, so this is an example of a map function, guys. So wherever you have to do an element wise operation for all the element, if you have to do a similar kind of operations, in that case, you can try to use a map function. You can try to write your own complex functions, maybe externally or maybe internally over here itself. And then you can do the implementation, you can do the calculation. Now let's try to understand another example of reduce. So map we have already able to understand. Now let's try to talk about the reduce. So how reduce is going to work and what reduce is going to do. Again, reduce is going to be a very, very useful function in general whenever you will try to solve some of the problem statement while writing a code. So reduce function is not available by default inside a Python library. You have to call it from a packages. So there is a package called as function tools. There is a package called as function tools. You have to import reduce from this one. There is a function called as reduce, which is available inside this particular package. So you have to do a first import of it. So import it first of all, and then you can do the implementation. So let's suppose I have a list. Okay, I have a list over here. And what I'm supposed to do is, I'm supposed to find out a summation of all the element. Reduce means reducing the data. Map means mapping the data. So just go after the name which is given inside a Python. So I have to write a code where I will be able to find out a summation of all the element which is available inside a list. I can simply call some function and I will be able to find out. I can write even external function. I will be iterate over to it and I will be able to do the same. But I wanted to do it in a bit different way this time. Okay. So maybe, so I can try to solve the same problem by calling sum and then list. I will be able to get a summation. I can even write external function and I will be able to do the summation. But here I'm supposed to do it in a different way by using a reduce function, let's suppose. So, okay, reduce I can try to call. Reduce takes again two parameter. One is a function and another one is a collection or iterable object. Okay, fine. So function wise, what I'm supposed to write? So function wise, I'm supposed to write take two elements x and y, add it. Simple. This is the only thing which I'm supposed to write it down. I'll show you how it is going to work. I'll show you the mechanism as well. So here, maybe I can write a lambda x comma y as an input it is going to take, means 2 input, and it is going to perform x plus y. Now here I can try to pass a list. So this is a function. It could be a lambda. I can even write external function. So function, and then it is going to return, which is going to take input as a x and y and going to return x plus y. So I can write even external function over here. So this is the function I'm writing, and then this is the collection which I'm trying to provide. Execute. Now 31 is something which I'm able to get. So the same outcome. So here 3 plus 4 plus 5 plus 6 plus 6 plus 7 is equals to 31 is something which I'm able to receive. Now how this function is working internally, let me explain you that particular part as well. So here you are writing lambda, right? This is the function which is going to perform the actual task. So here x and y. So what will happen? Let's suppose I have 3 comma 4 comma 5 comma 6 comma 6 comma 7. Okay, that's fine. Now this is going to be x, 4 is going to be y. In a first phase, this is going to be x and this is going to be y. Now x plus y, 7. Fine. Now 7 is going to be x, 5 is going to be y. Now 7 plus 5 is equals to 12. 7 plus 5 is equal to 12. Now 12 is going to be x, 6 is going to be y. Now 12 plus 6 is equals to 18. Now 18 is going to be x, 6 is going to be y, and 18 plus 6 is equals to 24. Okay. Now 24 is going to be x, 7 is going to be y, 24 plus 7 is equals to 31 is a final outcome which I am able to receive. This is how reduce is going to work. Reduce will keep on reducing the data. So always it is going to take two things, two parameter, one by one. It will keep on reducing the data, and finally it is going to give you the final outcome. This is how reduce function is going to work for you. Making sense to all of us, right, guys? Okay. Now I'll try to do a little bit of alteration inside the reduce function. I'll show you something different over here. So let me wipe it out. Okay. So here, let's suppose I'm going to write the same thing, but here x plus y, and then I'm going to take 3 parameter z, and then I'm going to do x plus y plus z over here, x plus y plus z. Execute. Now it is giving me this error, missing one required positional argument z. Why it is giving me this error? Let's try to understand this particular part. Now here, let me call list. This is my list on which I am trying to perform the addition operation. I'll try to show you with the help of same example. So here I have a data 3, 4, 5, 6, 6 and 7. Okay. So x, then y, and then z. That's fine. So x, y and z, x plus y plus z. So x plus y plus z. So 4 plus 3, 7. 7 plus 5 is equals to 12. Now this will become x, and then this is y, and then this is z. So x plus y plus z. So which is nothing but like 12 plus 6, 18. 18 plus 6 is equals to 24. Now this will become x. This will become y. Now I do not have a z. I do not have a z. And that is the reason it is giving me this kind of issues. Now you can just break argument over here with me, saying that what if I'm going to consider this list, but I can try to add one element, maybe a 4 over here. Is it going to work in that case? Is it going to work in that case? Okay, let me show you that. So let's suppose x I have, y I have, and then I have added one more element 4 over here, right? One more element 4 over here I'm going to add. Now this is going to be z. So x, y, z is equals to 35. It should ideally give me a result for this particular case if this is the list element, but it is not going to give me because this is not going to be the generalized one, right? This is not going to be the generalized one. So reduce function is not going to, whatever function you are going to take inside the reduce function, right? Whatever function you are going to write inside the reduce function, it should never a function which should take 3 argument. It should always take how many argument? Only 2 argument at any point of a time, because in every case you can't generalize this one, but for 2 you can generalize this one. Now again there is a edge cases. When I'm saying that you can generalize it, so again there is a edge cases. Let's suppose I'm going to call the same reduce function. Okay, and here let's suppose I'm going to take L1 as a list, and this list is going to be blank. Now is it going to work? Let's suppose I'm going to take only 2 parameter, okay, x and y. Is it going to work? Execute. L1 I'm supposed to take. Okay, so with 0 parameter it's not working. right? With zero parameter it's not working because there is no value. So reduce of the empty iterable with no initial values, with the empty iterable. This is the empty, right? Now let's copy the same. So with empty it's not working. I'll give only one element, one, not two, only one element. Now see the magic, it's working. There is edge case, it's working, right? So when you are going to pass only one element, now you can break argument with me saying that you just have a x, only one value, where is y? So ideally it should not work, but this is a edge case inside a reduce. So it is going to work for you. It is not going to complain even if I have only one element inside my collection. I can't write x plus y plus z. That's true. I can't even go ahead with the computation of a empty collection. That's true. But with one, it is going to work. This is one of the edge case you will be able to find out with respect to a reduce function. Although it doesn't look correct, but it is going to work. So just an exception inside a reduce, you all will be able to find out. Okay. Now, so reduce means I'm looking for just one single outcome. That is the meaning of a reduce. Map means I'm looking for the entire collection, and on entire collections element, I'm trying to perform some sort of a operations. Now let's try to understand another use case, another example of it. So let's suppose I have a list, right? I have a list. Inside this list, I have a data set. Now I'm supposed to find out a maximum. So what is a maximum element available inside this particular list? Means finally I'm looking for only one element, right? Finally, I'm looking for only one element over here. So I'm supposed to find out the maximum element out of this entire list. So whatever list that we have, I'm just looking for one element, which is going to be the maximum. So I have to filter out a max. I can even write a simple max function and I will be able to find out. So max, and inside that just pass a list. I will be able to find out that what is the maximum element. Okay, I'm able to find out, but I have to do it in a reduced way. How I can do it? Let's do it. And then reduce, reduce. So one element I'm looking for, reduce takes only two parameter. One is a function, another one is a collection. So here I can write a function which will do just a comparison between two number. So I can write a lambda and maybe an external function I can try to write. So here it is going to take two argument x and y, and it is going to compare. So it is going to give me x if x is greater than y. Else it is going to give me y. Else it should return me y over here. And then this is the function. This is the function. I can write even external function. I can call it over here. That is going to work. Just like I have called it inside a map. And here I can try to pass my list. I'm able to get the outcome. So what it is trying to perform internally. Let me show you the explanation. So x is going to be 4. Y is going to be 5. So y is going to be 5. X is greater than y. So 4 is greater than y. False, else y. So return 5. Now 5 is going to be x. 6 is going to be y. Do the comparison. Return what? Return y, which is going to be 6. 6 is going to be x. 7 is going to be y. Return what? Return 7. 7 is going to be x. And then 8 is going to be y. So in this fashion, it will keep on doing a comparison between two numbers. So do the comparison between two numbers. Find one that is going to be x. The next is going to be y. So it will keep on doing a comparison, and finally you will be able to get the biggest number. So whatever biggest number that you have. So even in this way, I can try to solve the same problem. So you can go in either of the way, because coding is just like a storytelling, right? So I can write my own story in my own way. Simple. Okay, now here, let's suppose I have a list, and inside a list, I have SUDH, I have basically KUMAR, and I have basically PYTHON. Now someone is telling you that try to concatenate all the data. Whatever data that you have, concatenate it and then give me a result. Means I'm looking for only one outcome. This is what reduce does. So I have to reduce this entire collection. So maybe I can try to call a reduce function. I can try to write maybe a lambda, 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 which is going to take two input x and y, and then just concatenate it. Just concatenate it, and here I'm going to pass the list. So here you will be able to find out that x is this, y is this, x plus y. Then x is going to be the whole, and then y, x plus y. Simple. And you will be able to get the final result. Here again and again I'm writing a lambda function. So instead of doing this, maybe I can write def, and then concat is an external function I'm going to write, which is going to take two arguments x and y, and then return what? Return x plus y over here. So here I can try to call reduce and then concat, concat, and then I can try to pass a list. Same result you will be able to get. So you can write either lambda or maybe either external function. It is just looking for a function. That's it. Nothing more than that. It is just looking for the function and your work will be done with respect to this one. Okay, so this is another example of a reduce function, guys. Now, maybe let's suppose I can try to show you some other example of a reduce a function. Okay, so let's take one different example, bit different example. So I have a list. Inside this, I have a list 4 element. Then again, I have a list with the 4 element. Then I have a list with the 4 element. So we have basically a list over here, as you can see. And basically, I have a list inside a list. This is the kind of a data set that I have. Now, what I'm supposed to do is I'm supposed to find out an intersection of, right, intersection of this list inside a list. Means I have a multiple list. I just have to find out what is a intersection of a list. Intersection means what is a common element between all of these 3 lists that I have. So maybe I can try to put 4 over here so that I can have 4, 4, 4 in all of this 3 list. Let's do it. So here I can write reduce, and inside that the first argument is going to be a function. So I can write a lambda over here, and I can try to take 2 argument as an input. And then what I can do is I can try to write set of x, means whatever argument it is going to take, and set of basically a y, because I have to find out the intersection over here. So y, and then I can try to pass the list. Now it is giving me what? What is the intersection of this list? Means what is a common element which is available between all these 3 lists? Yes, 4 is a common element. Let me remove this one. There is no common element which is available. No common element, right? Let's suppose I have like a 3 over here. So 3, 3, 3. Yes, there is a common. Maybe I can try to mention 4 over here. So yes, 3, 4. 3, 4 is a common. So intersection of the list I'm able to find out. So it is going to take 2 lists. First, how it is going to work internally? Let me explain you even with the pen. So x is going to be this, y is going to be this. It is going to do set of x. Set of x means remove all the duplicate from here, and then set of y, remove all the duplicate. And it is trying to do set of x and y. So and is going to perform what? And is going to take out the common element in between. And then again, so I will be able to find out one common. So common is basically 3, 4. So this is going to be x and this is going to be y. So again, find the same thing, remove all the duplicate and then try to find the common one. This is what it is going to perform internally, and you will be able to get this particular common element. Okay, fine. Now, let's try to understand some of the example with respect to a filter. So we are able to understand map. Map is just trying to do a mapping. We are able to understand a reduce. Reduce is trying to like reduce the entire, squeeze the entire collection into one, depends upon the cases. Now filter, as its name suggests, it will try to filter out something. Yes, it will try to filter out something from the collection based on the function which I am going to write. So let's try to like do it. So here is a list. Let's suppose here is a list that I have. Now I have a multiple element inside this particular list. What I'm supposed to do is I'm supposed to filter out all the odd number from this particular list. Filter out all the odd number out of this one. Odd number means a number which is not divisible by 2. This is something which I'm supposed to find out. Okay, fine. So means I have to filter out the data. I have to filter out the data out of this one. I can write even a custom function. I can even write the lambda function, external lambda function, a full scale lambda function, right? And I can do it. But this time I would like to use an inbuilt function called as filter function. And with the help of this inbuilt filter function, I would like to solve the same use cases. So again, just like a map and reduce, filter also takes 2 arguments. One is a function, which will try to do a comparison. The another one is a list or collections. Any collection you can try to pass. So here, if I have to filter out a data, I can write a logic maybe over here. So I can write a full scale function or maybe a lambda over here. So lambda, take one input. So take one input and then try to check whether this is going to be the odd number or not. So odd number, so means divided by remainder of not equal to 0. Okay, not equal to 0. Equal to 0 means even number, not equal to 0 means odd number. Okay, this is the simple argument which I am going to pass, and then try to pass this particular list. This is the custom function and this is the list I'm trying to pass. Now execute. It is going to give me the object. If I have to see the data, maybe I can convert it into a list or maybe a tuples and I can see the data. Now here you will be able to find out that it is working. It is working. Now how it is working? Let me explain you the internal mechanism. So here it is mapping. It is mapping each and every element with this function, with this particular function. This function is taking how many argument? Only one, right? So it will take 4, let's suppose. It will take 4, right? 4. Now this is going to give me what? This is going to give me true or false. So in case of filter, it always accepts a function which is going to give me true and false. So it will check 4 is true according to this or not. So 4 remainder 2 is equals to 0. 0 is not equal to 0. It's going to be false. So this is going, this is going to be false. Yes, this is going to be false. Now for 5, x is equal to 5. So for this, it is going to be true. For this, it is going to be false. For this, it is going to be false. For this, it is going to be false. Sorry, I have written in an incorrect way. 6 is false. 7 is true. 7 is true. 8 is false. 89 is true. 8 is basically false. 9 is true. So true, false, true, false, true, false, true, false. Now what filter does? Filter will always try to filter out only those data where outcome for this operation is going to be true. Only true, right? So wherever there is a true, it will extract the data. It will try to filter. This is how filter is going to work internally. So hope you all are able to understand the mechanism behind this filter operation. So simple, I have to write the function which will check each and every element and then check whether it's a true or false. True means it will try to give a return. It will try to give you the final data set. Let me show you some other example. So here again I have a list, and inside this list I have some empty element. So here SUDH, and again I have an empty element. I have KUMAR. So this is the list which I have. I have to filter out only a non-empty data. Means this is empty, there is no data. There is a data, there is no data, there is a data. So I have to filter out only a non-empty data out of this entire list which I have. How I will be able to do it? Let's try to understand. I can simply call filter function over here, okay? And I have to pass some functions, right? I have to pass some functions over here. I can simply write non as a data type and then non as a data type and pass a list. Execute, and let me convert it into a list. It's a very simple and basic operations. I'm able to get it. Okay. So non is working as a function over here, as you can see inside this function. Okay. So it is able to filter out based on this. So wherever we have a none means no data, it is able to filter it out according to our requirement. Okay. Now let's suppose there is another list and there is a negative number. There is a positive number, right? There is a positive number, there is a negative number, there is a negative number, there is a negative number, there is a positive number. Now I have to filter out all the negative number out of this list. How I will be able to do it? Simple. So list of, inside this I can write a filter function. I can write maybe a lambda over here which will check true and false. So I have to filter out all the negative number, let's suppose. So it will try to check each and every element true or false. So whether minus 4 is negative or not, how I'll be able to check with the help of this function. So x, so if x is lesser than 0, right? So x is lesser than 0. In that case, this is going to be true. This is going to be true. X is lesser than 0. This is going to be false. So this is how it is going to label each and every data with true and false, true and false. I can pass a list and there is a data of all the negative number. So it is going to check element by element, element by element. It is going to return what? This is going to return what? True, false, true, false, true, false. Wherever it is true, filter will try to extract those data. Wherever it is false, it will not try to pick those data set at all. So in this way, filter function is going to work, and filter function is going to give you the final outcome. Now let's suppose there is a list, right? And I have a non-data. None means invalid data, or none. None is one of the data type. So I have basically HELLO, hello, and I have basically SUDH sud over here. Then again, I have none data over here. Then again, I have a numbers over here. I have a floating point numbers over here. I have a true over here. So I have this particular list. Now I have to prepare a final list where I should remove this none data type. None. Right? Because with none, I will not be able to perform any kind of a primitive operation. That's the reason. So I have to remove it. How I will be able to remove? Let's do it. So list, I can write a filter. So filter, and then here, maybe I can try to like write in this particular place. So wherever we have a none, simple, right? So it will be able to give me the result. Same thing I have written even over here, right? So wherever we have a none, just try to remove it and then give me the final result. So this is again another example of a filter function that you all will be able to find out. Now, so in this way, I can try to write any kind of a custom functions, and with the based on the custom function, I will be able to filter out the data set. Now let's try to understand some of the operation, which is a mixture of, right? Which is a mixture of filter and a map, or maybe filter reduce, or maybe map reduce. Let's try to understand a couple of more example with respect to that. So here, let's suppose I have a list which is given to me, and I have a data set. So 2, 1, 3, 4, 6, 7. Now I have an even number, I have an odd number inside this list. Now someone is asking me that try to give me a final list which should hold an square of, just a even number, not an odd number, right? So what I'm supposed to do? So first of all, I'm supposed to filter out all the odd numbers, and then I can write a function so which will try to do a square of each and every numbers, right? So filter and map, I can try to use it combinedly over here. So what I can do is, so maybe I can try to write a function over here, which is a map. So map will try to perform maybe an operations on a return of a filter. So first of all, I have to filter the data. Yes. First of all, I have to filter the data, and then I have to perform the square operation. So inside a map, I can write a lambda, so which will take one data set, and then return what? Return a square of it. Now here I have to write the data set. Now what kind of a data set on which I have to perform this square operation? So I have to perform this square operation only on what data? Only on the even data, right? But in this list, I have a even and odd both kind of a data. So what I can do is I can write maybe a filter function to prepare the data. So whatever data this filter is going to return, I'm going to perform a mapping operation only on those data. So filter. So again, I can write a lambda so that I will be able to filter out the data set. So lambda, it is going to take maybe a data X, and then it will try to check the evenness of the data, right, for this particular list. So this is going to return me. This is going to return me what? A list of a even number, or the collection of the even number. Then I'm trying to map this entire return of the data with this one. Means whatever data that we have, just map it with the square function. Map it with the square function, and that's it. Now let me enclose it within a list. My work will be done just with this one. So it is filtering out all the even number, as you can see, right? 2, 2, 4, and 6 is an even number. It is filtering out all the even number, which is nothing but a return of this one. And then with the help of this map function, it is trying to perform what? It is trying to perform the square operation. So map with filter, I'm able to perform with this example. Hope all of you are able to understand even this particular part, right? Now, let me show you some of the operations with respect to map and reduce together, right? Map and reduce together. So with the same example, let's suppose I'm going to take the same list over here, right? I'm going to take the same list over here. Now what I'm supposed to do is I'm supposed to perform I'm supposed to extract, first of all the even number. Fine. Then I'm supposed to find out the square of it. Okay. First step is filter out all the even number. Okay, fine. Then try to perform the square of it. Fine. And then try to give me the summation of all of these number. Whatever is the outcome, just give me the summation of each and everything. So what I can do is, this is the extension of the previous program, just this program, right? So this is already giving me this square list after filtering out the data from this list. So what I can do is I can just copy this one, right? And I can try to write a reduce. So reduce what? So take a lambda x comma y, try to do x plus y one by one, and then this one, then this one. So whatever data it is going to return, which is this data, try to perform a reduce operation on this one, 60. So 4 plus 4, 8, 8 plus 16 is equals 24, 24 plus 36 is equals to 60. So here is a result which I am able to receive, which is a combined example of reduce, map, and a filter operation. So again, depends upon the use cases. I can try to solve it one by one, but breaking down a problem statement is pretty much crucial. You all should know that how I will be able to break down a problem statement, then only you will be able to solve it. This is what I'm trying to do. So someone told me that filter out only the even number. So fine, filter out. Then perform the square of each and every element. Okay, done. Then someone is telling me that try to do the summation of each and every element. Done. I'm able to do it. So this is how things are going to work with a permutation combination of the coding. So hope all of you are enjoying this entire lecture, entire this Python lecture. You are learning something out of it. Do let me know if you have any kind of issues, if you are facing while doing a coding. Please ping me your code snippet so that I can try to resolve it. I can try to even fix it, and I'll be able to help you out in this way. So with that, thank you so much everyone. See you again in my next lecture.